My name is Grant Joy. I'm a DevOps engineer at Distill Networks. For those that aren't familiar, we block bots online, so things like site scraping, ticket scalping, ticket poaching, things like that. But what I'm going to talk about today is my experience with Vault and some of the issues and things that I ran into so that maybe you guys don't have to go through the same pain that I had to deal with. So I started with Vault about a year and a half ago. Before we made a decision to even go with Vault, the things that we needed to deal with were, TLS certs, environment variables, something better than Chef Vault, which I'll go into more detail. Anyone who's used Chef Vault probably knows how much of a pain it is. API tokens, just for connecting to other services, SSH login stuff, and then just random other things that we share in Office. So I'm going to start with some basics and then go pretty deep into this, so just to get you thinking about how this stuff works, and since I know everyone has different levels of familiarity with Vault. So this is what some basic code looks like. If we have a new app or a new user who needs access to Vault, you basically just hand off this script with a couple things. So you generate them a token, or at least in our case we do. You can generate them an LDAP auth, and they can use that as well. So I just generate them this token, pass it off, give them the keys, boom, they're in, that's it. They're able to read and write directly. So our infrastructure currently looks like 3 servers. We have the Raft algorithm working there. It's Consul with Vault sitting on top of each of these. And it's not vault.distill.com. So one of the design decisions that I ended up making, which looking back at it later, I'm not sure I would have gone in this direction, is to use HAProxy. The reason is, whenever you connect to Vault, you need to talk to the leader. You can't talk to the other ones. They will redirect you back, and you can end up in a redirect loop. So the way that I ended up getting around this was I used HAProxy to always point to the leader, and I used a health check to do this. In new versions of HAProxy, you can, after 0.8 or something like that, you can adjust where it routes to based on feedback from a service. So we do a health check, and we say, OK, which one's the leader? Let's route all the traffic that's trying to go to this address directly here. And this has worked out really well. So I know that it works well because I have to restart these machines fairly often whenever we do new releases, updates, security updates, everything like that. And it just has no problem rejoining the quorum and keeps going. So this is what our health checks actually look like. And these are, I thought that they would be really basic, but they ended up being pretty advanced and adjustable. So I would recommend throwing something on, like PagerDuty, on some of these more important ones, like the Vault service check. So this just tells you, OK, Vault went down, one of the nodes went down, someone needs to go take a look at this right now. I have this in place, but it's never actually fired because they just keep running. So that's the basic infrastructure setup. But what I would recommend is separating the end users, depending on who they are, as much as possible from Vault. So the way that I handled this was I created an API. It's running Ruby on Rails, and it allows LDAP logins. So I have people logging in with LDAP into the Rails application, or I have them using a CLI tool that I've also written. So the way that this actually works is they log in with Chrome or whatever browser and pull the token, add it to their environment variables, and then you're able to use their specific token to connect into Rails. And then all the work just happens on the back end. So this allows people to, let's say they need to generate a Redis password. Well, they don't need to actually know what the password is. They don't even need to know that they generated a Redis password. But it did happen on the back end, and it's saved in Vault so that ops can go see it, or when the bootstrapping process happens of a new machine, it pulls it directly from there. So we saw kind of the code that I showed earlier. This is what the code actually looks like within Ruby. So this gem, highly recommended. It's Vault Ruby. It just gives you access to your Vault using Ruby, if you're going in that direction. So this is some actual code that we use, which is writing a new certificate into Vault and then reading it later on. So after that piece is started, we get into the actual bootstrapping process, which becomes quite complex. So I'll walk through the workflow of what this looks like. So it starts with a support user or a customer who says, OK, we have a new machine. We need to provision this. So this hits the public. They go to the public portal. This is the user. Public portal hits the public API, and then this makes a call into the ops API. This is the piece that I manage. And this is blocked by a firewall. This is not really necessary, but it helps me sleep at night. So I save the credentials to Vault, and at this point, we're able to bootstrap the node in Chef. So the way that Chef Vault really works is everything is encrypted for particular machines. And that's an issue if you're trying to share a similar token, say, across all of your different machines. Say that token changed, you'd have to re-encrypt it for all of the machines. So my solution there is I bootstrap it and give it the ability to connect to Vault, to connect to the HashiCorp Vault instead of connecting to Chef Vault, which is how we used to do all of our variables. OK, so inside of Ops API, we get this request that says, OK, we have a new machine that we need to create. I automatically do a knife bootstrap, so I set the box up basically to hook into Vault and write those environment variables that they need to connect into the path that has the things that they're looking for there. So later on, we need to run Chef on this box. At this point, we've set the box up to be able to run everything it needs. So someone needs to either log into the box or you trigger something from Ops API, and this just runs Chef on the machine. At that point, it has the role that it needs because I'll show you in a second how it gets the role. But it's able to just pick up the new environment variables and just go. It just runs the whole thing, and you have a box that's securely bootstrapped. You have all the environment variables that you need. It's fantastic. So let's say your Redis password changed, and you need to restart Redis. This is where you can pull it directly from Vault. Notice that it changed, and it does a notify to the service and says, OK, let's just restart it. Another thing you can use are Consul templates, and I would highly recommend this because they hook into Vault directly. So let's say the Consul template changed and changed the config for one of your services. OK, let's automatically restart it. Boom, you're done. And it's that simple. So this is what the Bootstrap endpoint actually looks like. It's not generally hit manually. It's hit, as I showed, it actually goes through another API that lands here. But it takes in the host name, IP address, and which Chef server to bootstrap to. There's a couple other arguments that aren't really relevant here, but they're like, what type of server is it? And then you can do extra work around that needs to be provisioned in this way, or it needs to get these particular environment variables. And what this actually runs is stuff that I used to have to do manually, but don't anymore. So we bootstrap the machine. We give it a particular role, and this is the Chef run list of these are the things we're going to run. And then we trigger the writing of the Vault secrets, the Chef Vault secrets, so that it's able to connect into Vault. This is the bootstrapping process that allows it to do all the rest of its work through Vault secrets instead of having to mess with Chef Vault for all the other secrets. At this point, we need to trigger a Chef converge. And what this does is it will remove the Ubuntu user. It will basically lock out all of the stuff that was used to spin this machine up and just set the machine up as it's, make it ready for an end user, throw it into production as it is right there. Another thing I would mention here is some of this stuff you could probably handle in Packer a little bit better than this way. This way works fine for my use case, but there are cases where you want to throw Packer at this and kind of provision it so that it connects directly to LDAP on first spin up as opposed to having a bootstrap with a PAM key. OK, so I mentioned this a little bit, but I want to go over why Chef Vault is so much worse than HashiVault. So with Chef Vault, everything is encrypted for particular machines, right? So in order to view a secret that's saved in Chef Vault, you need to be on the list as a user to read it, or you need to be registered as a machine that you can decrypt that particular secret. This is a problem for secrets that may change or for secrets that need to be spread out across a lot of machines. Because what I ended up doing was every time we added a new machine, I had to rerun a knife refresh or a knife update to update the secrets. It's driving me crazy. So by kind of taking this piece out, it became a lot more automation and user-friendly. This is another big one here. The fact that you can use LDAP instead of having to try to decrypt the actual, this secret's specific to this box. You don't want to have to go and decrypt that. And also, it could be different for other boxes. Like, let's say that it changed, but you didn't refresh it. Well, you're not going to be able, you may have different secrets applying to separate boxes, and it's a juggling act at that point. So this is a chicken and egg situation where I'm using Chef Vault as a necessary evil to hook us into the HashiVault. So different tokens have different levels of access. So depending on the type of machine that you're creating, you don't want to just obviously give it root access. So let's say you have a particular set of machines that are, this is this type of machine. Okay, I'm going to give access to that particular box by bootstrapping this machine with that information that can connect there. So that's how I've differentiated where the different endpoints that you can connect to within Vault. And this also makes it easy for ops to view and change the data, and it's just overall more flexible. Okay, so I'm going to talk about a different use case that uses the stuff that I just talked about, but this is a way that I've given the ability for my devs to deploy code easily. So I wrote a deploy script. It's published in Artifactory as a gem. So they just go in and download it. They can just run a gem update if they need to get changes as I make them. And it gives them the ability to run this command that says, OK, I want to deploy an app. Here's the name of the app. And do I want to deploy it to staging, production, integration, whatever environment they need to, and then the branch that they want to send it to. So what actually happens on the back end is I take the information they passed across and I write it to Vault, and then I trigger a chef run that looks at Vault and says, OK, this is what the deploy should look like once it is actually running in production or wherever it is. A couple nice things that come out of this. It's all stored directly in Vault. You can store a history pretty easily, and I'll show how that works in a second here. And that makes it really nice for audit tracking and seeing who messed up the environment. I also use this CLI for the environment variables. So a lot of times these environment variables are, you don't want people looking at them unless they have specific access. You don't want people who are only pure devs and don't have access to prod to be able to see the prod environment variables, things like that. So I write them all to Vault, and then when Chef runs, it pulls them from Vault and just sets up the environment variables directly. So I talked about different levels of access, and it's really easy to deploy to multiple servers. So I can just put that as part of this deploy process that just SSHs into them and runs them, or you can do it through Ops API and run them there. So I'm going to go over some of what the actual code looks like for these cases. So here's what the example call would look like. So we're deploying our app to staging, and here's the name of the environment variable and the value that we're expecting. So I say, OK, let's set up the path. We've got the environment variable, the app name, and a key. This is whatever the key in the environment variable is going to be. I build up a time, and then I read the current value, compare it with the old value, and I say, OK, if it did change, then we're going to write this new one, and I write it to the current time and also the current. So whatever's in current here is going to end up being written when it actually runs. There's some value here in if someone messes up an environment variable, you have a running history going back of these are the changes and when they were made. And so the deploying of this runs similarly in that it sets an environment variable, or sets a variable that gets looked at when Chef runs. Specifically looking at the old branch, and this is kind of handled in a very similar way, but it doesn't actually get written as an environment variable. And then once this happens, I automatically trigger a Chef run. So currently the way I do this is people are able to log into specific machines. It writes the new branch, and then it just says, OK, let's run this thing, and SSHs them in and triggers the Chef run. I'm moving to using Ops API to handle that so that they don't need to have any SSH access at all, and that's kind of what I would recommend. The other thing that's really nice is you can just notify from Slack directly from the CLI if you would like. So everyone has visibility on when these things went live. OK, so I'll talk about what the actual code looks like on the Chef side. Everything that I've talked about so far, that code was running on the client side. So as I mentioned, we write the credentials to HashiVault, and then Chef triggers. So during this process, we're going in and saying, OK, let's git pull origin and then the branch that they just set it to. this will trigger, because the service changed, it will trigger a restart, and the application restarts. So within Chef, I just pull in the Chef gem for Vault, and I'm able to read the secrets about the app name and the environment. So this gives you the information to connect into Vault. The token that it uses here is a token that has access only to the paths that it needs, so that we don't give too much access to this particular Chef machine. It can only see the environment variables that it needs. So then I build up so for example, we need to get the Ruby cert. So I just pull it, I say, okay, let's make the group, write it, and then you have access, and you can just do this, which is look at all of the secrets in this particular path and convert them into environment variables. So I just iterate over all of these, do a little bit of magic here to make it run properly when it lands into an export file. And then you end up with all of these variables securely on your end machine. So that wraps up the Chef side of things. I'm going to talk about Let's Encrypt a little bit. So Let's Encrypt is a free certificate provider, and it's a pretty new thing. I think it started less than a year ago. The code's all open source. It's running something called Boulder. You can go look it up and read it for yourself. It's awesome code. It's very reliable. They're adding wildcard certs. They don't have them quite yet, but in January they are going to, which is a really big deal. As it is right now, I have to use global sign for wildcard certs, and global sign sucks. So certificates always last 90 days. You can't change that, and as I mentioned, it has a better interface than most of the for-pay CAs. And as an aside, just so you guys don't have to learn this the hard way, if you unsubscribe from that mailing list, you can't resubscribe ever. So I'll talk about what this looks like in the basic terms, and then how it differs if you're actually a CDN. So if you're creating a new certificate for Let's Encrypt, the first thing that I do is I register the key with Let's Encrypt. And they pass back some information to me. I save it, or I actually write that directly to Vault. Then I say, okay, I want to make a new cert, and I want to associate it with that key that I just generated. So your key is associated with an email, and it uses that for the encryption, just because they will encrypt it using the public key and pass this back to you. So we request a cert with a common name and aliases. It generates, on the Let's Encrypt side, they generate a challenge token, pass it back to you. I save that to Vault. And then I request verification from Let's Encrypt. What happens in here is I take this and I drop it in place so that when I say, okay, I'm ready to confirm that I own this, they go and they look at the location that they said where you need to drop the token, and then say, okay, you're good, or no, you did something wrong here. Once you get that piece working, and there's two ways to do it. So there's DNS or HTTP. DNS being, you can see my examples here. DNS being, you set the TXT record for, it's always this same thing. So my company, distillnetworks.com, they're going to tell you, okay, you need to take this token and you need to set the TXT record for _acme-challenge dot whatever the rest of it is. That's the DNS. If you do HTTP validation, it's appended to the URL, so it's always whatever it is, .well-known / acme-challenge, and then you drop the token in place. So once you've dropped that in place, you're able to obtain the Let's Encrypt cert. This is just saying, okay, you've verified for all of the SANs that it's good. And then I pull the cert down, save it to Vault. At this point, I'm able to print it. I'm able to push it to all of the load balancers, and then it's in play. So when you're a CDN, you're hosting a whole bunch of different URLs. It's not like you have just Distill networks or whatever it is. So what we do is we pull in anything, so we have the star here, and say anything that's trying to go to this .well-known / acme-challenge / whatever, we know what they're doing. We know we're trying to do a Let's Encrypt renewal. So we automatically use HTTP validation, and we say, we're just going to steal all that traffic that's trying to go to our end user, and we're going to reroute it back to our own server. This server just has all of our tokens sitting there, and then anything that needs to will be validated. The important thing is not so much that other people don't get access to that, but because there's nothing you can really do if you get access to this token except for generate the certificate. But they wouldn't be able to generate the certificate just by having the token. You would have to own the domain. So that's kind of what I just described. The pushing to load balancers process has been a challenge for us, but I think that's just part of the game. The renewal piece, we do this every 2 months because, as I mentioned, the maximum is 3 months. It gives us a 1 month gap for making sure that everything is as is expected. A lot of times, a customer will have 4 of 5 domains on us, but that 5th one will block our renewal. Then we need to go talk to them and say, okay, what are you actually doing with this domain? Are you going to put it on our network, or are we going to drop it from the cert? And working things out like that, it's nice to have that extra month there. But for the most part, once you work through those kinks, the customer doesn't need to be involved. They don't even need to know what's happening, which is great. So here's a script that I wrote to take a look at when certs are going to expire. So this is really basic. It took me like an afternoon to write. I just say, do a vault list on secrets, let's encrypt, certificates. This is where they're held. I split it out, and then I just say, OK, for each of these, I'm going to do a test and say, I download the cert, this right here, this line, downloads the cert. And then I say, I'm going to run OpenSSL X509, no out, end date. This pulls all the end dates, throws them in here under expirations. Then I sort them, and then I print how long it's going to be until the expiration, throw in some colors just to make it easier to read. So this gives you an output that looks like this. The people that run this are the support team at my company, and they say these are the ones that they're really looking at. These are the ones that are expiring soon. These are ones that have expired for one reason or another. But these ones expiring soon are the ones that they really need to look into and be on top of making sure that they're getting them renewed. OK, so the last thing I was going to talk about is multi-factor auth and one of the ways that you could do this. So I'm sure you guys are probably familiar with PCI compliance and the fact that you need to use multi-factor auth to log into your machines. One of the ways that we were thinking about handling this at Distill was we're going to use a jump box. We're going to require YubiKey SSH into the jump box, and then from there we can use Vault SSH. So Vault SSH is interesting in that the receiving machine has to be running this Vault SSH helper, right? So we log in, and then this part happens through LDAP. We didn't end up going in this direction, though I would have liked to, just because there were too many random concerns. But I think a lot of those have been addressed since I started doing this. So I would still highly recommend going in this direction. So in my use case, I use LDAP for handling that auth. But these other ones are just as good, of course. So we got tokens. Tokens is what we generally use. This is what you use for any application that needs to connect. LDAP, that's pretty universal for my company. And then GitHub, I think, is a nice solution, too, especially for devs. It's more common than LDAP, and they have better control over it. They can reset their password, things like that. They don't need to ask the ops team. And then as far as secret backends, I mostly just use the generic backend. If you use the Vault Ruby gem, you can take the whole object, so say the object that's returned from Let's Encrypt, and you just throw it at the generic backend, and then when you pull it out of the database, it's already as an object, which is fantastic. You can just treat it as an object the whole way through instead of trying to use the PKI backend, which is cool, but using the PKI backend means you need to kind of massage it into data that's ready to be pushed there. SSH certs and RabbitMQ, I think, are also some interesting backends that you can do some kind of cool things with. OK, so if you want to learn more about this stuff, I wrote a blog post that's on the HashiCorp website. It's called Distill Network Securely Stores and Manages Their Secrets with Vault and Consul. And you can email me if you have questions. But the real answers are going to come from the Vault Tool Google group. They were extremely helpful when I was setting this up. On the blog post, I just went into more detail, and I have all these code examples there. So if you want to see the code as I used it, it's all right there. I have a few minutes if you guys want to ask me some questions.
Since you're already storing your certs in Vault, why not distribute them to roll them to your Consul?
That would be a nice thing to do if I had the time to do that instead of other people managing that part of the infrastructure. I think it's a good idea, though. Anyone else? Cool.